I'm going to look at this integral informally and formally. So the informal one is what you want to work towards as you're practicing and getting better at calculus. This is how people who use calculus to do other things like physics, this is how they think of it. So I'm staring at this and I see that the derivative of the denominator is basically the numerator. Well, that looks like a derivative of a natural log of a cosine. So that would give you 1 over the cosine multiplied by the derivative of cosine. It's the chain rule. So I'm thinking chain rule backwards. It takes a little getting used to. But one adjustment I want to make before I do the integral is to make it so the numerator is literally the derivative of the denominator instead of just kind of like it. So that's negative sign. So I multiply the interior by -1 and I'll compensate by multiplying the exterior by -1. And now I've got this expression where I have a function in the denominator and the exact derivative of that in the numerator. This came from the natural log. So I have negative natural log absolute value cosine x. And I'm just sort of mentally checking real quick to make sure I did it right. If I differentiate this, I would get 1 over cosine multiplied by the derivative of cosine, which is negative sine. So this is good. And then the whole thing is going to be evaluated from pi over 4 to pi over 3. So my upper limit, negative natural log, and the absolute values aren't going to matter because these are positive values of cosine. So natural log cosine of pi over 3, which is 1/2. Subtract the lower limit, which gives me a plus. It's a double negative. Natural log cosine pi over 4, which is 1 over root 2. This gives us an opportunity to kind of play around with log rules to make the answer look nicer. So I'm just going to do that real quick. So I get negative natural log 2 to the -1, and then I'll use the power rule on that. And then this one, natural log 2 to the -1/2. So bring down this power out in front, and I get natural log 2. Bring down this power in front, and I get -1/2 natural log of 2. Well, that's cool. And then I have one of these things minus 1/2 of 1, so there's 1/2 of a natural log 2 left. Or you could write it natural log 2 all divided by 2, which might look even cooler. So let's check out our formal approach to this. And I'm going to go ahead and just make some more room for myself real quick. And there we go. So we'll do it formally this time. The formal approach, you still have to recognize the basic relationship that I recognized when I started the informal approach. The idea is that it looks like the derivative of the denominator is basically sitting up in the numerator. So I'm going to give the denominator a simple name. I'm going to call it u. Let u equal cosine x. Then du is going to be negative sine x dx. And I'm going to start transforming my integral. So I could write it first like this. And what I did there was just sneak a factor of 1 into the integrand so that I could have du appear exactly. So negative sine x dx, that's du. Then I'll do the transformation to being a u integral instead of an x integral. And now it looks like du over u, and I go, oh yeah, it really is a natural log. So I could transform the limits of integration here. I'm going to go ahead and take that approach because I don't do it enough on average. So what I mean is that you better not put a pi over 4 here and a pi over 3 here because those are limits on x. Those are not limits on u. So I can say when x is equal to pi over 4, u is equal to, I'm looking at this, the definition of u, cosine x. So cosine pi over 4, which is 1 over root 2. When x is equal to pi over 3, u is equal to the cosine of pi over 3, which is 1/2. And so this is now is transformed into a u integral. And I go from 1 over root 2 to 1/2. Okay. So this is the natural log absolute value of u evaluated from 1 over root 2 with 1/2. Again, the absolute value bars don't do anything there because these are both positive values of u. And everything works out the same way as it did before. I get natural log 1/2, negative natural log 1/2, plus natural log 1/√2. Same answer as I got before.